everyone! Today we're going to be learning about proportions, and our goals today are to identify a proportion or define what a proportion is. Then we're going to learn how to solve proportions by cross multiplying, and then use proportions to find unknown values, such as in a word problem or a real life application. Okay, so to start with, a proportion is an equation where two fractions are set equal to each other. So you may have heard the word proportion before, and people don't always think of it this way, but it's really just two equivalent fractions, and you set them equal to each other with an equation or with an equal sign. So here's an example. On this one, we know that the two fractions are equal because if you multiply the first fraction by 3 over 3, you would get the second fraction. Now you can also have proportions which have variables in them, and you could maybe find the missing number. In this case, x should equal 1 because that's what would create an equivalent set of fractions here. It would make a true equation. Okay, now for proportions, we have something called the cross product property, which says that the product of the means is equal to the product of the extremes. So we've got extremes being the a and the d. They're kind of like opposites. One is in the numerator of the first fraction and one is in the denominator of the second fraction. Those are called the extremes. And then the means are actually the opposite ones. So the denominator of the first fraction and the numerator of the second fraction. And it turns out that with proportions or with equivalent fractions, the product of the extremes is equal to the product of the means. And what that tells us is that if you multiply a and d together, you get the same number as when you multiply b and c together. So if you cross multiply here between this proportion, you'll get the same answers for both pieces. So remember this, the product of the extremes is equal to the product of the means. Okay, this is important for later on. We're going to learn a little more about cross multiplying now. So again, it's called the cross product property, but I like to call it cross multiplying. What you do is you multiply across the proportions. So you kind of make a cross when you do it. So 3 times 4 would be 12. And then you would do 2 times 6, and you would also get 12. So this is indeed a true proportion. These two fractions are definitely equivalent to each other because the product of the extremes was equal to the product of the means. Okay, so we got the same thing for both sides. Now, you can use this idea to help you solve proportions which have variables in them. So if you need to figure out what number the variable should be, you can use the cross product property, or you can cross multiply. So I'm going to take you through an example. I always like to write the original problem down, even though I already see it. So I wrote 8 over x equals 6 over 15. And then we use the cross product property, which says to do 8 times 15 and x times 6. So I'm going to write that down here. 8 times 15 should equal x times 6. It's important to write that equal sign in between so that you know what equation you're still solving. And then we simply simplify. We do 8 times 15 and we get 120. And then I kind of move things around on the right side. You don't have to do that. And then at the very end, we need to say, well, this is 6 times x. So how do I get rid of the 6 that's multiplied by x? And the way you do that is you divide by 6 on both sides. So I'm going to write that in, divide by 6, and the 6's will divide out to be 1's, and then I have x equals 20 at the end. So the solution for x is 20. Now, that might not be what you thought at the beginning. Some people look at it, at the proportion, and they say, well, if I add 2 to this one, maybe I'll put it over here, then I would get 8. And so if I add 2 to this one, I would get 17. So x should be 17. But that's not what we got when we did our cross multiplying. And cross multiplication is the only way to go here. Proportions, it doesn't mean that you can get an equivalent fraction by just adding a number to the numerator and denominator. Fractions don't work like that. Fractions are related, the numerator and the denominator are related to each other by division. So we really can't use addition or subtraction to go about getting an equivalent fraction. So don't do that. Use your cross multiplying method. All right, here's another example. But this one is not written in a proportion for us yet, or in the fraction form of a proportion. So when you see one like this, 5 is to 4 as 45 is to x, this right here represents one fraction, this first part of the sentence. This second part of the sentence represents the second fraction. So I'm doing 5 is to 4, okay, so comparing 5 and 4, as, okay, so that as is kind of translating to an equal sign here, 45 is to x. And notice how I went in the same order. So if 5 is first, then I put it in the numerator. For the second fraction, 45 came first, so I put it in the numerator. Okay? And then once you've got your proportion written down, you can now use the cross product property, or cross multiply. So we're going to do 5 times x, and we're going to do 4 times 45, set that equal to each other. So 4 times 45 ends up being 180. Whoops. I'm thinking while I'm writing. Okay, so 4 times 45 is 180. And at the very end, we're going to divide by 5 on both sides to get that x alone. That's going to get rid of the 5 that's being multiplied to x, and I now have x equals 36. So I'm going to write some steps over here, which always will work when you are solving a proportion. First, you cross multiply, and then you always divide at the end. That's always the way it ends up working out. Okay, so here's another one, and I'm going to take you through this one as well. So we've got 2 different fractions again. 6 is to 4 as x is to 18. So I want you to think about how that would look if you wrote it out with fractions. So a numerator and denominator, and then another numerator and denominator. And if I put it in the same order, I have 6 in the numerator and then x in the other numerator. So 6 over 4 and then equals x over 18. And then we're going to cross multiply. Okay, so 6 times 18, 4 times x. And you can kind of write it in different orders depending on what you like. I put 4 times x first for this one and then 6 times 18. Now 6 times 18 will give us 108. So when I do 4 times x, I should be getting 108 in order to make this a true proportion. So now I'm going to divide both sides by 4. This is step number 2, divide. And I cancel out the 4's, and I now have that x equals 27. And that's the final answer for this one. Okay, so I have one more proportion for you to try. And so I'd like you to pause the recording right now and try this one out on your own. Okay, I'm going to put up my work here. When I cross multiplied, I got 16 times m equals 8, because 2 times 4 is 8. And then I divided both sides by 16, and the 16's canceled out, but then I had 8 over 16. So check your answer. It should not be 2, because the 8 is in the numerator. So when you simplify this fraction and divide the numerator and denominator by 8, we actually get 1 over 2. And that's the final answer. So 1 over 2 is a different answer than 2 over 1. So make sure you're getting the right answer. And it's okay that it's a fraction. Okay, I have a few word problems as well. which this is our last objective for today. So we want to use proportions to find unknown values in real situations. So here's an example of someone earning money. Sylvia made $208 for working 13 hours. At the same rate, oh, and this is a typo here. How many hours would she have to work to make $176? Okay, so our goal here is to write a proportion and use that proportion to solve this scenario and figure out how many hours Sylvia needs to work. So there's our question. That's our unknown. So I'm going to say that the number of hours that she needs to work to make $176, we're going to call that X. And then I need to set up a proportion, which is a fraction equal to another fraction. My first fraction is going to be made up of this first sentence, $208 in 13 hours. Okay, so I'm putting it up here. Notice that the second fraction that I created, the 176, comes from the second sentence. But instead of a number of hours, I had to say X hours. Okay, so there's some corresponding information here. And when you write a proportion, it's very important to keep the units consistent. So if you use dollars in the numerator, you have to do that for both fractions. And then you would use the other units, the hours, in the denominator. You can't mix it up. You can't put like 208 in the numerator on one side and then on the other side put the 176 in the denominator. You have to make the units match in your two fractions. Now, this is not the only proportion that I could have written, but this is the one I'm going to go with. Okay, so I'm going to cross multiply now because our goal is to solve for x. And I would get 208x equals 13 times 176. And then I need to do the 13 times the 176, and I would get 2,288. And then at the end, I need to get that x by itself. So I'm going to divide by 208. And once I do that, my 208s divide out, and I would get that x equals just 11. So in 11 hours, Sylvia would make $176 using the same rate of pay as they describe. Okay, so we learned a little bit on this one about how to set up a proportion, which is the most challenging part of solving the problem. So I have another one that I'm going to show you before I have you try one on your own, and that is this. Aaron drove 845 miles in 13 hours. At this same rate, how long would it take him to drive 585 miles? Okay, first, figure out what they want you to know. They want to know how long it would take. How long? That would be like hours. So x is in hours. Okay, so that's going to match somewhere in our proportion with the 13 hours. And then we start using that first sentence to create a fraction. So we've got 845 miles in 13 hours. Okay, so I'm going to put that up there, but the other fraction is coming from 585 miles and x hours. So we have to be careful. We can't just go in the order of the sentences because the miles have to match. So if I use 845 in the numerator on the left side, I have to use 585 miles for the other side on the numerator because I need my units to match. So I'm putting hours then in the denominator. Okay, so now I'm going to cross multiply. We're looking for the number of hours it takes to drive 585 miles. So cross multiplying, we have 845 times x equals 13 times 585. And then we simplify a little bit to get 845x equals 7,605. And then divide both sides by 845. And then I'll have my x alone, and x will just be 9. And then going back to what I was looking for. I was looking for number of hours. So the units for my 9 would be 9 hours. All right, so that gives you a couple ideas about how to solve these. Okay, so make sure that your units are matching when you write your proportion. Now here's our last problem. I'm going to read it with you. At Ace Hardware, 11 inches of wire costs 33 cents. At this same rate, how much money will 100 inches of wire cost? I'm going to circle what we're looking for. How much money? Okay, that's going to be in dollars. And then I'm going to let you practice writing your proportion. This is the hardest part, is setting it up. But if you can figure out how to make your units match and how to create two fractions and set them equal to each other, then you're going to be good to go. So go ahead and pause the recording and think about this problem. And when you're ready, unpause the recording to check your answer. All right. Now, your proportion may look different than mine depending on how you did it, but I chose to put inches in the numerator and then cents in the denominator. So for my first set of numbers, I had 11 inches with 33 cents. So that's this fraction right here. And then my second fraction is how much money, so the x has to go in the denominator with the cents. And then the 100 inches will go in the numerator. So make sure that your units are at least matching numerator and denominator. And then once you cross multiply, whoops, I meant to circle this, you'll get 11 times x equals 33 times 100. So I'm going to put that up there. 11 times x equals 33 times 100. And then simplifying, I have 11x equals 3,300. And then we divide both sides by 11. I'm going to divide out those 11s, and I get x equals 300. So 300 cents. Now, usually you don't go to the store and say, okay, that costs 300 cents. You would change it to dollars. So 100 cents is $1. So in other words, this is $3 for the 100 inches of wire. All right, so we have now finished our 3 objectives today about proportions. And so I'd like you to go ahead and pull up a message to me and answer these 5 questions in your message and then send that off to me so you can finish earning your points for the asynchronous session. And thank you so much for watching. And as always, if you have a question about this lesson or any of your lessons, feel free to call me or message me or email me, and I will get back to you as soon as possible. Thanks, and have a great day.